Okay, should we get going? We're a little bit behind with where I was hoping to be with these lectures, but it's not the end of the world, everything's going to be fine. So we still haven't quite finished product differentiation. So we're just going to start by going through a model of vertical product differentiation. And you've got a mock test in front of you. You see one of the questions there is on vertical product differentiation. This might not necessarily be exactly what you need. Okay, with the questions on the test, you need to think a bit about what you need to do. And they're supposed to be, it's supposed to be a kind of hard question, but requires some thought. But it's easy because you know you're going to get the same question in the exam. So you've got a week to think about how you're supposed to be answering these questions. And you've got a choice of two, you only answer one in the exam. It's all written on the front of the paper. You know, I think it's quite doable. The second question was the end of term test 2 years ago. The first question was the end of term test 1 year ago. People did fine both those years. You have choice this year, so you should do even better than people did in the last 2 years. Okay, so yeah, we're going to start with this model of vertical product differentiation, so consumers' preference for quality. Then we're going to look at some empirical work on product differentiation, and we're just going to note a few caveats on other phenomena that can give very similar results for differentiated products, even when products are all actually the same. What are you missing? What?
Yeah, I thought so.
It was the last one, what?
Correct.
And then we're going to go on to start talking about advertising. Advertising isn't on the test. You know, you can see that from the test paper that's in front of you. But this stuff might be useful for the test, it might not. So previously we looked at horizontal differentiation, where different consumers prefer different products. Okay, so even if the two products were priced at the same level, some consumers would prefer one product, some consumers would prefer another product. You know, so in this hoteling line model, it was some consumers would prefer to go left because they were closer to the left, some consumers would prefer to go right. And if you think about it as a metaphor for, I don't know, how spicy food is, you know, some consumers like spicy food, some consumers don't like spicy food. Now we're going to look at vertical differentiation, which are models when if the goods were priced at the same level, everyone would prefer the same good. Okay, but maybe when they're priced differently, different consumers then prefer different goods. Okay, so the natural way of thinking about these vertical differentiation models is in terms of quality. Okay, so some goods are going to be high quality, some goods are going to be low quality. Some consumers are going to really value quality, some consumers aren't going to be so bothered about quality. So, you know, you can think about, there's Waitrose out there. Waitrose is selling their pod-filled pasta, and then there's Tesco value-filled pasta, which costs 50p or something. Okay, and
If I sit here, will it affect your camera?
well, so if you sit down, and then the person behind you can tell.
I think it's alright.
Should be alright.
The director's like,
I've been a bit bad about putting the videos on YouTube, by the way. Last night I put up the last 2 lectures. So everything's on there now. I've had a very busy few weeks, but it's all up now. Okay, so the model we're going to be looking at is this model by Shapes and Sutton, 1982. And we're going to be 2 firms, and they're going to produce goods of different qualities. Okay, so firm 1 is going to produce a good of quality S1, and they're going to charge a price P1. Firm 2 is producing a good of quality S2 and charging a price P2. And we're going to have S1 less than S2. Okay, so firm 1 is for low quality firm, firm 2 is for high quality firm. Okay, so this is Tesco, this is Waitrose, if you like. And they're both going to have 0 marginal cost to produce the good, to make our life easier. Okay, and just like in the models of horizontal differentiation that we looked at, there's going to be a unit mass of consumers, and they're going to be indexed by some parameter. Okay, so we're going to call the parameter theta. And theta is going to measure how much consumers like, how much they value quality. Okay, so from a straight line from 0 to 1. What am I telling you? Okay, so how do these consumers differ? Okay, so we know there's a unit mass of them. How do they differ? Well, the consumer located at a point theta, so we're just going to call him theta. Consumer theta, they get a surplus of V, which is their valuation, base valuation for the good, plus theta times the quality of the good minus the price from buying the good. Okay, so a standard model would be a consumer gets a surplus of their valuation minus the price. Now we have this extra term, which is the extra value they get from consuming a high quality good. Okay, so theta times S, which is the quality. So the higher theta is, the more they're going to value high quality goods. So consumers at the right hand side, consumers for whom theta equals 1, they're going to really value high quality goods. Consumers at the left hand side aren't going to care about quality at all. Okay? If theta is 0, then the consumer will get the same surplus whether or not the good is a high quality one or a low quality good. Okay, so if you like, these are posh people who shop at Waitrose. These are, I don't know, who else shops at Tesco? Students. I didn't want to say. Okay. So these consumers with low theta, they're quite happy to buy Tesco value products. Consumers high theta, they want Sainsbury's taste for difference or Waitrose. Okay, but if Sainsbury's and Tesco were the same price, given the choice, everyone would buy from Sainsbury's. Okay, the only reason people buy from Tesco is that they're cheaper than Sainsbury's. So that's why it's vertical differentiation rather than horizontal differentiation. So the way you solve this model is really just the same as the way you solve the standard horizontal differentiation model. Okay, so when we're solving these horizontal differentiation models, the first thing you do is you find the different consumer. And that's what you're going to do here as well. Okay, so we're going to find the consumer who's just indifferent between buying from a high quality firm and buying from the low quality firm. Okay, so as you move along this line, you start to value quality more and more. So people on this far side are very likely to buy from the high quality firm. People on this far side are very likely to buy from the low quality firm. Okay, and somewhere in the middle there's going to be a consumer located at a point that we say theta star, who's just indifferent between buying from the low quality firm and buying from the high quality firm. Okay, so what does it mean for them to be indifferent? Well, they must get the same surplus from buying from either firm. Okay, so here's their surplus. So if they buy from the low quality firm, they get a surplus of, let me put this back, so they get surplus of V plus theta 1, theta, so they're located at theta star, times S1 is the quality of the first firm, minus P1, which is the price of the first firm is settling. So that's the surplus they get if they buy from the first firm. If they buy from a right-hand firm, a high-quality one, well, they get a surplus of V plus theta star S2 minus P2. For handouts and lecture notes. Okay, so if they're indifferent between the two things, their value from buying from the left-hand firm must be the same as their value from buying from a right-hand firm. Okay, so these two things have to be equal. And that's what I've written on the slide here. Okay, you can just, the two V's cancel out. So you can cancel out the V's from either side, and you get what's written on the board there. So their location times the quantity of firm 1 minus the price of firm 1 should be equal to the same thing as firm 2. If they're going to be indifferent between buying from either firm. Okay, so if we know this, we can solve for where this indifferent consumer actually is. So we've got theta star S2 here. Let's take P2 over to this side. Okay, then we're going to have a P2 minus P1. And let's take theta star S1 over to this side, and then we get theta star S2 minus theta star S1. Okay, then we can just divide through by S2 minus S1, and you get this expression. Is that clear? Or should I? Yeah. Okay, so we know where the indifferent consumer is. So if this is where the indifferent consumer is, then all of these guys, they're going to buy from Tesco, and all of these guys, they're going to buy from Sainsbury's. Okay, anyone to the left of the indifferent consumer must prefer the low quality firm, anyone to the right of it must prefer the high quality firm. Okay, so if this whole distance is 1, then the number of people buying from the low quality firm is going to be theta star, and the number of people buying from the high quality firm is going to be 1 minus theta star. Okay, so it's everyone else. So once you know this, you can work out the profits of the two firms. Okay, so excuse me, they have 0 costs, these two firms. So profits are just going to be price times quantity. The price set by firm 1 is P1, we've said that already. Quantity sold to the low quality firm is theta star, so all the guys on the left there. Okay, so their profits are going to be P1 times this theta star. And yeah, you can just multiply that in, and so you get P1, P2 minus P1 squared. Okay. Firm 1 is going to choose their price in order to maximize their profits. Okay. So with the maximum, we have the first order condition. So we're just going to differentiate this with respect to P1. Okay. So when we differentiate the first bit, we've got P1 there, so that's going to drop out, and this means P2 over S2 minus S1. So then when we differentiate, minus P1 squared, we're going to get minus 2P1. Okay, which is what we have. So there's no price on the bottom, so it doesn't matter. Okay, we're just differentiating the price. So yeah, later on we'll think about these qualities being endogenous. Maybe we'll think about firms choosing what qualities to produce, but then it'll be a multi-stage game. Okay, so at this point in the game, the firms are just choosing what price to set. And then you can simplify this expression. You've got S2 minus S1, multiply both sides by that, it just disappears. Okay, so naught there, so P1 must be equal to P2 over 2. So already this is telling us quite a lot, isn't it? So the low quality firm is selling a price of half the high quality firm. So that makes sense. Tesco is normally cheaper than Sainsbury's. So it's intuitive, right? And you do the same thing for the high quality firm. So the price set by the high quality firm is P2. The quantity they sell is 1 minus theta star. Remember, here's the indifferent consumer. All of these people to the right of the indifferent consumer are going to buy from a high quality firm. So that's 1 minus theta star. So again, you can just substitute our expression for theta star in here and multiply out. So we get P2 minus P2 times theta star. This is this thing. So for first order conditions, is going to say, well, the derivative of P2 with respect to P2 is just 1. Okay. Derivative of P2 squared gives us 2P2, and derivative of P2 times P1 gives us P1. Okay. That's it. So let me write this down. So if you add this bit to both sides, okay, you get 1 is equal to 2P2 minus P1 over S2 minus S1. And then if you times both sides by S2 minus S1, you get S2 minus S1 is equal to 2P2 minus P1. Okay, so P2 is going to be what we've got on the slide there. So we've got P2 is going to be equal to P1 plus S2 minus S1. Okay, so P2 is half of that. P1 plus S2 minus S1. So again, does this make sense? Well, the high quality firm's price is increasing in the low quality firm's price. And it's also increasing in the difference in quality between them. Okay, so if they're both producing goods of the same quality, so say S2 was equal to S1, then there would really be no difference between these two firms at all. And this equation would say P1 is P2 over 2, this equation would say P2 is P1 over 2. So what would the prices be? What would be the solution then? So P1 is half P2 and P2 is half P1. What are P1 and P2? Come on. So if S2 is equal to S1, this equation is saying P2 is P1 over 2. So what are the prices in that case? Zero, yeah, thank you. They're both 0. Okay, so in that case, look, 0 is 0 divided by 2, 0 is 0 divided by 2, okay? So in that case, you know, they're producing the same good, they're producing goods of the same quality. So in that case, you just get perfect competition. Okay, the price is being pushed down to marginal cost. Okay, so when they're producing goods of the same quality, they both set the same price, but both set a price of 0. The only way they're going to set different prices is if there's some difference in quality between the two. Okay, and this difference in quality is enabling them to get some monopoly power, if you like, by producing a high quality good. Waitrose captures this market of people who really value, you know, high quality, whatever it is Waitrose sells. You know, so the bigger the difference in quality between the two firms, the higher the price that the high quality firm is going to be able to get away with selling. So you can maybe already guess if firms are allowed to choose S2 and S1 optimally, what do you think they're going to choose? Exactly, yeah. So in this model, Waitrose is going to want to be as posh as possible, Tesco is going to want to be as cheap as possible. So anyway, we've got these two equations, P1 was P2 over 2, P2 was this thing over 2. We can substitute this one into this one. I'll do that on the board. Let me go to okay, so P1 was P2 over 2, and P2 P1 S2. Okay, so if you substitute this one into that one, okay, you get P2 is equal to P2 over 2 plus S2 minus S1 all over 2. So we've got, this is a quarter of P2. There's a P2 there as well. So we've got, if we subtract a quarter P2 from both sides, we get 3/4 P2 is equal to S2 minus S1. Okay, so P2 is equal to 4/3 of S2 minus S1. Where have I gone wrong?
Is it S2 minus S1 over 2, so?
Yes, yeah, well done. Okay, so good that someone's paying attention. Okay, so that's that one. And then you know that P1 is P2 over 2. Okay, so you divide this by 2 and you get 1/3. Okay, so this is the equilibrium prices in this game. And just as I was saying, the prices are increasing in the difference between the two firms. Okay, the more different these firms are, the higher the market power each of them gets. Okay, because they're each going to be serving a particular bit of the market. So with this particular value for P1 and P2, the solution, we can substitute that back into our original equation for the location of the indifferent consumer. And you're going to get P2 minus P1, well that's going to be 2/3 S2 minus S1 minus 1/3 S2 minus S1. Okay, so P2 minus P1 is just going to be a third of S2 minus S1. And then when we divide that by S2 minus S1, we're just going to get a third. Okay, so the indifferent consumer here is going to be located 1/3 of the way along. And I just went to that from there. So if that's where the indifferent consumer is, then we can work out what profits the two firms are going to make. Okay, so the location of the indifferent consumer just tells us the demand that's going for the low quantity firm. So the profits of a low quantity firm are its price times the indifferent consumer. Okay, its price was this thing. The indifferent consumer was at 1/3. Okay, so the profits made by the first firm are going to be 1/9 of S2 minus S1. Okay, which is what we've got there. And then, well, what's the demand going to the high quantity firm in this model? 2/3, yeah. So the indifferent consumer's at 1/3. Okay, so everything else is going to the high quantity firm. That's 2/3. That's everything that's left over. Okay, so there's 2/3 is the demand going to the high quantity firm. They're setting a price for this thing. Okay, so we get 2/3 times all of this. So 2/3 times 2/3 is 4/9. And that's what we have there. So the second firm is making profits of 4/9. That's 2 months. So, you know, it's maybe slightly surprising that Waitrose are making higher profits than Tesco in this model. You know, in reality, Tesco certainly make higher profits than Waitrose overall. Here, what's happening is, well, because they're selling this high quality good, and for some people that really value high quality goods, it's like they have more market power to sell, so they can get away with charging higher prices. And it turns out here that they also have high demand. So there are two different factors that are increasing their profits. They have high demand, and they're able to get away with charging very high prices. And both profits are increasing this gap between the high quality firm and the low quality firm. So both firms would like this gap to be as wide as possible. Okay, so if you give Waitrose the choice about what quality to produce, it's going to choose S2 as high as possible, so maybe 1 is the maximum. If 1's the maximum, it's going to choose 1. So they're going to want to be as far apart as possible. And remember when we looked at the hoteling model, there were these two effects that determined how close the firms wanted to be. So there was the strategic effect that says, well, if you go further apart, then you escape from competition, you create market power for yourself. Okay, it means you can get away with charging a higher price. And then there was the demand effect that said if you come slightly closer, you can still demand off the other firm. And in this model, the strategic effect, okay, this creating market power thing, is dominating the demand effect. So that's why they want to be as far apart as possible. So that's all I'm going to say on the theory of product differentiation, and we'll just have a little bit of empirics just to remind you that there is a reality to all of this maths. So there's been a lot of empirical work through the years estimating demand functions in differentiated product markets. Okay, so seeing how differentiation in reality is enabling firms to get some market power. And so this is a textbook, Carlton and Perloff. The library has copies if you're really interested. There's a nice summary of some of the empirical work on this. And these papers often just take a characteristic approach. So they just run a regression where the consumer's valuation is on the left-hand side, and on the right-hand side you have a bunch of characteristics and the price and some other factors. So, you know, if you wanted a project to do in your undergrad thesis, this is something you could do in a project pretty easily. And it's used, you know, it seems pretty crude and simple, but it's used even in antitrust cases to work out what the consequences of a merger would be. Whether the combined firms would end up getting prices that were too high, or whether consumer services would go up or down after a merger. So this is quite a crude approach, and there's some more sophisticated research that's trying to quantify the gains from variety. So remember, in the Dixit-Stiglitz model we looked at, consumers, the more different products there were, the happier the consumers were. The more different types of breakfast cereal, if you like, the happier consumers were. So consumers always liked another breakfast cereal coming into the market. And even in the salad model as well, there were some gains from variety. Remember, we had consumers were located on a circle. If with just one firm, one product, then everyone has to buy that one product. Okay, and in the story of the model, that means these consumers really have to walk a long way to buy that product. If you're taking this metaphor view, where you view the location as a metaphor for preferences, then walking a long way means buying something you don't really like. Okay, so maybe you only like Cheerios, but Cheerios don't exist, so you're forced to buy normal Kellogg's cornflakes because you need to eat something in the morning, and it's quite painful for you to eat these cornflakes. Okay, but you don't have anything better to eat, so you don't have much choice. And then suddenly along comes Cheerios, and Cheerios introduce a product down here, and you that's almost your ideal product, right? You're really happy suddenly because this new product has been introduced. And in fact, I talk about Cheerios as a silly example, but that's what some of the empirical research looked at. Okay, so Houseman, he's quite a famous guy. So he tries to quantify the gain in consumer surplus from the introduction of apple cinnamon Cheerios. Has anyone tried? Do you get those in the UK? I don't think I would ever. But anyway, so in the US you must be able to get them. And apparently this increased the value of cereal consumption for an average consumer by 25%. So it's quite a big gain, right? 25% gain in consumer surplus from introducing this new product. And then you make some little adjustments because of imperfect competition. Okay, another product comes in. That means that that new product's going to create some market power, going to slightly increase prices for other products perhaps. Okay, so the gain in consumer surplus ends up being 20%, not 25%. So it seems like there are pretty high gains from introducing new products. Okay, so something the governments should be doing is encouraging the creation of products. That would be a conclusion from this line of research. Okay, so encouraging innovation that results in new products is a good thing for governments to be doing because it seems like there's too little of it according to this empirical work. And these guys, Broder and Weinstein, so this is a recent paper that was, macroeconomists got very excited by this paper. So what they do, so macro we look at inflation series, right? And inflation is quarterly data, and everything's aggregated together into one inflation series. And you can't learn very much from quarterly data. You can't really see what's going on. What Broder and Weinstein did is they used the scanners at checkouts in US supermarkets, and they recorded the price of every single good that went through the supermarket. Okay, so they have very fine level price data. They know exactly what each household is buying. They know exactly what price they're paying for those goods. So yeah, we've got a sample of 55,000 households. So it's quite a large sample, and they know every single good that those households are buying. And based on this sample, they work out that true inflation is overstated by about 1% a year. Okay, so if true inflation is overstated by 1% a year, that means real growth in the US is 1% higher than the statistics say it is. Okay, so growth is 3.5%, not 2.5%. So that's a pretty big difference, right? And this is because of the extra value that these consumers are getting from variety. So with this very fine level data, we're able to directly estimate what these consumers would be prepared to pay for another brand. Okay, and they find that these consumers really value variety, they're getting a lot of extra value from it, and this means that true inflation is overstated. And there's a nice quote here. They say, consumers are willing to pay around 7% of their income to access a set of goods available in 2003 relative to those available in 1994. So, if you were in 1994, you would pay 7% of your income in order to have, it's quite a lot of money, 7%, in order to have iPhones, everything, iPads, everything else that's come along in the last 8 years. Okay, so these tech companies introducing new products, they're creating an incredible amount of value, and they seem to be doing a lot of good in terms of social services. 1% a year, 1% on its own isn't very long, but over 100 years, 1% a year is an incredible amount. So this is quite important for big policy issues about what we should be encouraging, how happy consumers are, whether growth is good. Okay, just a final thing before we start talking about product differentiation. When you're looking at empirical work on product differentiation, you have to be careful to distinguish between situations where you're getting market power from product differentiation and situations where you're getting market power from some other mechanism. Okay, so we saw that collusion is one way firms can kind of generate market power themselves. But there's some others as well. So there's a whole chapter in Oshai about consumer search, which we're not going to have time to talk too much about. But if you have to pay a cost to go to the shop every time, you have to pay a cost to find out what the shop is selling, what price it's selling. Okay, then those costs mean you're not going to want to shop around too much. I could go to both Tesco's and Sainsbury's and Waitrose in order to compare the prices of whatever I'm buying, but it's a massive pain, right, to go to 3 different shops just to decide what you're going to buy in your weekly shop. More likely, you have this general impression that Tesco's is generally cheap, so you go to Tesco. Okay, but because you only have this general impression, Tesco can get away with charging quite high prices on some items, and you might not realise you're getting charged a high price on those items. Okay, so these search costs can very easily generate market power for firms. And there's an interesting paper. So Judd is a very, well, Burdett's also quite famous, but Judd is one of the most famous contemporary dynamic macroeconomists. And he's got quite an old paper from '83. So he supposes that consumers have to pay some cost to find out the prices that firms in the market are selling at. Okay, they're all selling exactly the same good. There's no difference between consumers. There's no difference between goods. But because consumers have to pay this search cost, turns out there's a mixed strategy equilibrium where firms choose a random price above marginal cost. Okay, so firms are making quite high profits in this equilibrium, and this is just because So you're a consumer. You go to the shop. You see some price, and it's very hard for you to know whether that price is high because the true price is high, or it's high because you happen to have gone to one of these firms that's charging a very high price. Okay, so maybe you go to 2 firms and you buy from the cheapest one, but it could be that both of those firms were still quite expensive objectively. Okay, so because consumers are only going to go to a few firms, these firms can get away with setting quite high prices in the long run. And then they have an extension where they suppose that some consumers have high search costs and some consumers have low search costs. So you might think of this as like tourists and locals in the town. If you go to a tourist village on the coast or something, the prices are really high in the shops in the centre because only the tourists are buying from those shops. And you can get a kind of sorting by search cost, where consumers who have a high search cost end up paying high prices. So tourists end up paying more than locals. So that's one way where you can get phenomena that look a lot like product differentiation, but they're not really. Switching costs are another one. So it's a similar thing. So all of your keyboards have QWERTY keyboards, right? The keys along the top are Q, W, E, R, T, Y. And the originally So the first typewriters, this is the year 1900 or something, very gigantic machines, they weren't QWERTY. Some smart guy came along and he looked at the frequency of letters in the English language and he put the letters that you use most closest to your fingers. Okay, so E would have been on this finger and T would have been on this finger, I think. So all the letters you used most were were on the middle row, close to your first two fingers. And what happened was that these typists were able to type so fast that they broke the machines. You know, these are clunky mechanical machines, and they were typing so fast that the machines all broke. So they deliberately slowed the typist down by putting letters in stupid places, and that's where the QWERTY keyboard comes from. Okay, so by any, this is true, by any standard, the QWERTY keyboard is a crazy keyboard to be using, but because everyone's used to the QWERTY keyboard, it's very hard for anyone to introduce a better keyboard. So that's an example of a switching cost, right? It costs you something to learn to use a new keyboard, so people get stuck with the keyboard very easily. And there are some other examples here as well. And I think changing bank accounts is a massive pain, right? You know, some bank accounts do this thing where they offer 5% interest for 1 year, and then it goes to 0. And what they're relying on is that you get the account, and then you can't be bothered to change once the interest goes to 0. And if you're anything like me, you probably won't change. Airlines have status points. You know, that's one way of getting lock-in. Keyboard, I talked about. And habits are similar. Okay, so if you always use one product, you just get used to it. Okay, there's no rational reason maybe for why you use that one rather than another. But if you get used to one product, you want to carry on using the product that you're used to, and that gives the firm some market power. Okay, so brief conclusion on product differentiation. So we showed that when the firms were choosing location, products won't be at the social optimum. Okay, the social optimum was 1/3, 2/3 in that hoteling model, and firms were choosing to be as far apart as possible with quadratic costs. We showed that price discrimination doesn't always increase products. Okay, yeah. So when products are differentiated, we showed that price discrimination can actually reduce profits. Okay, so we looked at price discrimination in the hoteling model, where firms could see where consumers had come from, and because the firms could see where the consumer had come from, that enabled them, that led to them competing in price for each different location. Okay, so price was forced down as far as it could at each different location. So price discrimination won't increase profits necessarily when there's product differentiation. We looked at this salad model and we showed that there was too much entry. And we showed that by creating lots of products, so by creating lots of different types of breakfast cereal, you can actually discourage entry by other firms, again in the salad model. And then today we looked at vertical differentiation, and we showed that firms want to produce as different qualities as possible, so you get a really high quality firm and a really low quality firm. And surprisingly, both firms are making profits, not just the high quality one. And we showed just now that there were very high returns to the variety. Okay, so let's take a short break, and then we'll start talking about advertising after the break. There will be, I'm not expecting think we've got a bit there with it. The last bit is Normally use a separate bag once a year.
Your culture is like 4 o'clock. Okay, should we get started again? Okay, so the final topic we're going to look at is advertising. So we'll do some now.
we might do some after the test, depending on how tired you are. If we don't do it after the test, we'll do it in the last lecture term. So it's up to you when you'd rather do it. To start with, do you guys think adverts work? Do adverts encourage you to buy something? No? Yeah. And how do you think they work? If you see an advert for something, why do you then go buy it? Okay, so one answer was because the advert makes you aware of the good. So that's kind of an informative role for advertising. Any other reasons you buy something? It's going to run out. Yeah, okay, so that's information as well. About quantity. Brand loyalty. Brand loyalty. Yeah. Yeah, so you see the advert, you realise the brand has produced a new product. Do adverts ever persuade you to buy something that you wouldn't have bought anyway? No?
Now, there seems to be sort of adverts used for brand sort of creation. So if we take the example of the Unilever adverts, basically they're all about sort of showing corporate responsibility. So the most recent one they've done for the soap that's been all over YouTube. Obviously, it's trying to strike an emotive chord about why should you bring a child into the world and stuff like that. So it's
that's an interesting case. So it's kind of showing good things about the product. So it's making you associate the products with nice things. So maybe when you buy the product, you maybe feel a bit better about yourself. So that's a kind of complementary view of advertising, where the advert is providing another good that's complementary to the original good. Okay, so by getting the advert, you're going to value consuming the original good a bit more, because seeing the advert and consuming the good are complements in some way. So we've had the informative, we've had the complementary, and there's also a persuasive view that just says adverts change your preferences. But it seems like you guys don't believe that adverts can be persuasive. They are. So there's a bit of all three, I think. And the final question I have here is why should we care about advertising?
So if it changes your preferences, then it's something that's quite important to take note of.
Yeah, so if it changes preferences, that's important. If it creates market power, that can be important. We care about maximising social welfare. If adverts are just enabling firms to charge higher prices, then that sounds like adverts might be very bad for social welfare. But if adverts are providing a complementary good, then adverts might be good for social welfare, okay? There might be too little advertising if adverts are complementary to the product. So we're going to look at these three different views, okay? So this first view, so this is the one that a lot of the literature likes these days, this persuasive view, and it's discussed in Oshai in level 1. Sorry, this isn't what people like. This is the old-fashioned view of advertising, I should say. Sorry. So the persuasive view is people have some preferences, they see an advert, their preferences change. Okay? So this is the original analysis of advertising that was done in the 50s or something. People were looking at this persuasive view. So once you see an advert, you're then more inclined to substitute between a rival's product and the advertised product. Okay? So demand becomes less elastic. You're less willing to substitute, right? So demand is less elastic. Okay, so you see some adverts for Nike trainers, and after seeing those adverts, you no longer want to buy the cheap knockoff. Was it Hitachi or something, isn't there? Yeah. High-tech. Okay? You no longer want to buy the high-tech trainers because you've seen these brilliant adverts by Nike with Michael Jordan jumping or something. So it reduces your willingness to substitute between high-tech trainers and okay? And it's also creating barriers to entry. I remember when I was in primary school, everyone got very upset. What brand trainers you were wearing really mattered when you're that old. And, you see little kids in the shops and they're screaming to their mum, "I don't want a trainer, I want a Nike trainer." That was my best little kid voice. Why, if you were high tech, why would you bother with entering the market in that world? People don't want a trainer full stop. They want a trainer made by that particular brand. Okay, so this is what advertising does, but it can be very bad for welfare because it's really creating a lot of market power. Okay, so high market power, high deadweight loss, etc. So this is suggesting advertising is a bad thing, but it's anti-competitive. But it's not quite complete. It's not completely clear because if preferences are changing, how are we supposed to analyze welfare? Okay, we think about preferences. Welfare, it's consumer surplus plus producer surplus, and that's the integral under the demand curve. It's the area under the demand curve. Okay, but if that demand curve is changing because of advertising, then it's not clear what welfare is anymore. Do you take the welfare before? Do you take the welfare after? Or is it irrelevant? Okay, so we'll look at these different ways of measuring welfare on this advertising. So that's the first view. A slightly more modern view about how advertising works is this informative view. And this is what you started with. So this is advertising, it's providing some information about the product. So it's price, its availability, its quality, where you can buy it, all of these things. I don't know, a lot of adverts for washing powder used to be like this. But, Daz was 50p cheaper than its closest rival. Really, really low budget supermarkets have a lot of advertising on price. So Iceland always advertises on price. You never see price mentioned in a Sainsbury's advert. Well, maybe you do occasionally, but normally Sainsbury's is, these are really high quality products. Isn't Sainsbury's brilliant? If you look at Iceland, this turkey only costs £3. Do you really want to eat a £3 turkey from Iceland? Or about how effective the product is. So a lot of cleaning products say Ariel cleans a lot better than Persil. So they have that thing at the end of the advert where they dip the two things in, the stain comes off on one, and even if an advert isn't providing direct information, it can still provide some indirect information. Okay, so Virgin, I guess when I wrote these slides, Virgin were running some adverts that seemed really expensive and glossy. You might think, well, if Virgin weren't a respectable airline, they wouldn't be able to afford to produce such adverts. Because, if they were bad, no one would fly with them more than once, so they'd probably go out of business. Okay, so the fact that they can afford to spend lots of money on advertising already maybe tells you something about the quality of the product. And this informative view of advertising is going to suggest that advertising will encourage entry, or will help entry, because if a new brand can advertise their product, that's going to help them get demand for their new product. Okay, so it's going to slightly reduce the disadvantage that new entrants have to a market. So, this informative view of advertising is maybe saying that advertising is a good thing. Okay, information is generally a good thing. Information about price should help with competition. Okay, so if you believe this informative view about advertising, it's probably good. And the final view is this complementary view. And this Bagwell paper that I cite here, I haven't told you to read any other papers, I think, in the whole of this course. This is one that it might be worth reading, or at least reading the introduction and the conclusion. So it's a big literature survey of the advertising literature, and he talks a lot about this complementary view in particular. So what this view says is it's a view that maybe only an economist could come up with. So the view is that advertising is providing a complementary good to a product being advertised. I don't know, there was a brilliant South Park episode a few series ago were about Toyota Priuses. And these Toyota Priuses were generating smog, not smog, smog. Okay, so you buy the Toyota Prius and it makes you feel so good about yourself, because and the adverts are contributing to that, right? The adverts are saying, oh, it's wonderful. If you buy this car, you're a wonderful person. Isn't it so good that you care about the environment? Blah, 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 blah. Okay, so the advertising is providing this complementary good. It's providing this feeling of smugness about yourself. So this is one way of thinking about adverts. Okay, or another example. If you look at adverts for fast cars, they're always implausibly attractive people with implausibly large amounts of money. And so you think, or at least some subconscious part of your brain maybe thinks, but well, if I buy that car, maybe then I will be implausibly attractive and have ridiculous amounts of money. And also when you see someone else driving a Porsche, maybe you think the same thing about that. Okay, so the fact that you've seen the advert, so what I say here. Good. Okay, so if you, the driver, value being considered high status, then seeing a Porsche advert will be complementary to owning a Porsche. Because so once you've seen the advert, you realise that other people will have seen the advert as well, and those people that see it will then be thinking that you're attractive and high status and rich and all of these things. Okay, so seeing the advert tells you that it's going to have this effect on other people, and other people are going to associate you driving the car with being attractive. So it's a slightly strange idea, this complementary view, but you can start to see how it might make sense. This Bagwell paper talks a lot about that. And you can also think of the complementary view as a more sophisticated version of a persuasive view. So any story you can tell with a persuasive view, you can probably also tell with this complementary view. So the persuasive view is, you saw the advert, it changed your preferences. And here, you're saying, well, you saw the advert, yes, your demand curve for the original product changed, but that's just because you just received a complementary good. If I give you a left shoe, then your demand curve for right shoes shifts upwards. Okay, so that's the model here. I give you an advert, your demand curve for the good that's being advertised shifts upwards. It's not that when I give you a left shoe, your preference for right shoes changes. It's that left shoes and right shoes are complementary goods. So any story you can tell with a persuasive view, you can kind of reinterpret in this complementary view, and that way you don't have to think about preferences changing. Okay, because economists generally don't like preferences changing. Economists think preferences are something we're born with, and you can't do anything to change your preferences. But maybe that's a silly position, and economists take it a bit too far. But it certainly helps the theory of preferences don't change. And if you reinterpret the persuasive story in this way, then the welfare consequences are going to be quite different. Okay, with a persuasive view, preferences were changing, and that was enabling firms to extract some market power, and you thought there was probably too much advertising. But if advertising is complementary, then there might be too little advertising. Maybe by producing more adverts, people will feel even better about themselves when they drive Toyota Priuses. Maybe the government should be producing adverts for Toyota Priuses just to make Toyota Prius drivers feel that much better about themselves. So the welfare consequences here might be quite different. Okay, so this view is suggesting that maybe there's too little advertising, not too much. Okay, so these are the three views that you should always have in the back of your mind. And now we're going to look at some mathematical examples in a slightly more stylized cases. Okay, and we'll talk later about how the particular views map into this example that we're going to look Okay, so all we're going to do is we're going to assume that from somewhere there's a demand curve for a good, okay, and the demand is a function of the price and the amount of advertising. And there's just going to be one firm, okay, and the firm is going to choose advertising first and then price. We're going to assume the constant margin cost is C, and we're going to assume constant margin cost for advertising is R. Okay, so producing each unit of advertising costs you R. And this is the Dorfman-Steiner model from 1954. So it's quite an old. Okay, so it's really just a standard monopoly problem. It's not at all difficult. Profits are price minus cost times quantity. So that's standard, and then we just have this extra bit, which is minus the expenditure on advertising. So there's going to be a first order condition for price. So what price are you going to set? Well, using the product rule here, we have derivative of this times that. Okay, derivative of this is just 1 with respect to price. Plus this times the derivative of that. Okay, I've just written this as del Q del P. Price doesn't occur here, so there's nothing to do there. So just rewriting this expression, what have I done? So if you multiply this expression by P over Q, okay, Q times P over Q is just P, and then we introduce this P over Q term there. Okay, so once you multiply by P over Q, this thing here, what's this thing? Yeah, this would be price elasticity of demand. I said on the slides, didn't I? So let's call this price elasticity of demand epsilon P. Okay, so this expression, yeah, you've seen this before. It's saying the price and price minus cost times epsilon, or just rearranging it, it's saying that the markup, price minus cost over price, is equal to minus 1 over the elasticity. So this is standard, you've seen this much before. But there's also going to be a first order condition for advertising. Okay, this firm is choosing both price and advertising. So what's the first order condition for advertising? Well, it's going to be very similar. Okay, derivative of this bit with respect to advertising is 0. Advertising doesn't occur in there. So I should have said that they're choosing price and advertising simultaneously. It's not a superfunction. So all we have is the derivative of this with respect to advertising minus R in the first order condition. And then we're going to do the same thing that we did before. So before we multiplied by P over Q to get the price elasticity of demand. Now we're going to multiply by A over Q to get the advertising elasticity of demand. Okay, so we multiply both bits by A over Q. You get an A over Q there, and you get A over Q times R there. So this thing we call the advertising elasticity of demand. Okay, so it's the increase in demand, the percentage increase in demand that results from a percentage increase in advertising. And we're going to call that epsilon A. So just plugging epsilon A in here, this says the price minus cost times epsilon A minus this thing is equal to 0. So if we rearrange this, so we have price minus cost times epsilon A is equal to A over Q times R. Okay, so we want something with price minus cost over price. So price minus cost over price, well that's going to be this thing divided by epsilon A divided by P. Okay, so A over Q times R times P over epsilon A. Okay, we just divided by P and divided by epsilon A. No, sorry, we multiply. I've got this wrong. Sorry. So we divide both sides by P times epsilon A. and that's what's on the board. Okay, so yeah, let's just say this one. So what we have here is we have R times A. What's R times A? What does that mean? Yeah, total expenditure on advertising. And P times Q is, we know, that's total revenue. Okay. So this is expenditure on advertising times divided by income, all times 1 over this elasticity of advertising, price elasticity of advertising. Quantity. So what we've got one equation for price minus cost over P here. We've got another equation for price minus cost over price here. So we can put the two things together, and that's going to tell us what this has to be true. Okay. And remember that the price elasticity of demand are always negative. Okay, demand curve sloped down, so the price elasticity of demand is negative. So minus 1 over that is going to be something positive. So we can just write it the same way as the absolute value. Okay. So if we multiply both sides by epsilon A, we have epsilon A over the absolute value of epsilon P is equal to this. Okay, so expenditure on advertising divided by revenue should be equal to the ratio of these elasticities. And this gets called the Dorfman-Steiner condition because it's both sides of the greater. So this is immediately telling you when you should expect advertising expenditure to be high relative to sales income. Okay, so this thing is going to be high compared to this thing, when this thing is high compared to that thing, basically. Okay, so when either the advertising elasticity of demand is high, so 1 unit of advertising increases demand by a lot, or when the price elasticity of demand is low. Okay, so low means close to 0. Okay, it's high as the elasticity is negative. Close to 0. So when demand is very price inelastic. So when demand is price inelastic, it means firms have a lot of monopoly power. They can get away with charging a high markup without there being too much effect on the quantity that's demanded. Okay, so if they can get away with charging high markups and advertising enables them to charge a higher markup, then they're going to want to perform lots of advertising. Okay, so these are according to this model, there are 2 times when we should expect to see lots of advertising. Okay, either when advertising is very effective, or when firms just have a lot of monopoly power to start with. And then finally, the final thing that you can note from the simple model is that we had this expression for the markup. Okay, you can solve this for the price as well. So the only advertising isn't appearing in here. The only way advertising is going to have an effect on the price is if it has an effect on the price elasticity of demand. Okay, so if advertising has no effect on the price elasticity of demand, then the price isn't going to change whether there's more or less advertising. The only way advertising is going to have an effect is if more advertising makes demand less elastic. So that's what you might expect. Advertising is going to reduce this elasticity, and that's going to increase the price. So what we want to know is what the effect of advertising on this price elasticity of demand is going to be. Okay, and that's what we're looking at in the next few slides. So let's think again about these different views of advertising that we started with. Well, you can think of the persuasive and the complementary views as shifting the demand curve. Okay, once you see the advert, you just demand more of a product. Okay, so maybe a reasonable model for what this demand function is that the quantity you demand is some function of the amount of advertising you see, and some plus some function of the price. Okay, so advertising is just shifting the demand curve up and down. So this is like the demand curve when you don't see any advertising at all. That G function. Okay, and you, if you wanted, you could do some. This is an exercise, if you like. You can do some tedious algebra, and if the second derivative of the price of this G function is negative, then advertising will increase the price. Okay. So what does so G is like, I said, G was like a demand curve when there was no advertising. And if you draw a demand curve, you normally draw something like this, don't you? It's curving that way. Okay, so the first derivative of that function, well, that is negative, and it looks something like that. And the second derivative looks something like that. Okay, so the first derivative is going to 0 because it's getting flatter and flatter. And so the second derivative is also going to 0. And the second derivative is positive. So with a demand curve that slopes like that, the second derivative is positive. So with a kind of standard demand curve, this isn't true, so this won't be true. So in fact, advertising will reduce the price, not increase the price. Okay, with linear demand, what's the second derivative of linear demand? You all look so glum. It's nearly Christmas. It's St. Nicholas's Day today. You should all be happy. Yeah. It's in Romania. It's really presents today. So what's the second derivative? Yeah, so the first derivative is constant, so the second derivative is 0. Okay, so with linear demand, this thing is equal to 0. Okay, so price, advertising will increase the price with linear demand. So with things like this, it won't. With things like that, it will. Okay, and this, in fact, I say this on the slide, don't I? So this is going to be true for linear demand, but it's not true for isoelastic demand, which we looked at a lot. So, you can construct quite plausible examples in which advertising actually results in a decrease of the price, not an increase of the price. So it's certainly not automatic, but even in a model like this, advertising is going to be a bad thing. So this was kind of a persuasive and complementary view, increasing the demand level curve, just shifting it out. Informative advertising you might think as scaling the demand. So if you don't see the informative, maybe there are 100 consumers out there, and maybe 10 of them know about the product even without seeing the advert. Everyone has the same preferences, but once some adverts are sent out, more consumers find out about the product, and the aggregate demand curve is just scaled upwards. Okay, so maybe a reasonable model, if you believe the informative view, is that this demand function is some function of the amount of advertising times some function of the price. So in this case, well, price elasticity of demand does not depend on A. So remember, the price elasticity of demand is this expression. So we had Q, P, A is this what it was? No, it's the other way around. F of A, G of P. Is that what I have? Yeah. Okay, so what's dq dp? Well, dq dp is just going to be f of A times g dash p. Okay, and we want dq dp times p over q. Okay, so p over q and dq dp. Okay, so that's going to be price divided by f of A g of p times f of A g dash the F of A is cancelled, so this is price times G dash P over G of P. So in this multiplicative case, the elasticity wasn't a function of the amount of advertising that was before. Okay. So advertising is not going to have any effect at all on the price. So if you think advertising is just about information, then you shouldn't expect advertising to change the price too much. Oh, I do. I didn't see I did it on the slide. Okay. That's just the same as what I have. Okay, so we've looked at what the effect of advertising on price is. You know, intuitively you think that probably if it increases price it's going to be bad, if it decreases price it's going to be good. But let's check that. Let's look at welfare. And this is what these guys, Dixon and Norman, did in '78. And we're going to start by measuring welfare with respect to a fixed standard. Okay. Remember that if advertising is changing preferences, then it's not immediately obvious, but it makes sense to use a fixed standard. So we're either going to measure welfare with respect to consumer preferences before they saw the advert, or we're going to measure welfare with respect to their preferences after they saw the advert. It won't really matter which way round we do it, as long as we're using a fixed standard, not changing the standard before and after. Okay. Okay, so we're going to define a few things. Okay, we're going to start by defining SP as consumer surplus. So when they buy the goods for a price P. And what we're assuming, because we're taking their preferences either before advertising or before they saw the advert or after they saw the advert, we're just saying that there's no direct effect of advertising on consumer surplus. Okay, so, you know, if you're using changing preferences, you might look at consumer surplus with the old demand curve before and with the new demand curve after. Here we're just using one set of preferences, either preferences before or preferences after. Okay, so there's advertising isn't directly affecting consumer surplus, it's only affecting it via the price. And we're going to define V of Q as the maximum amount consumers would be prepared to pay to purchase the quantity Q. So it's going to help if I draw a picture. Okay, so here's price, here's quantity, here's the demand curve. Okay, so suppose the price is here, P, okay, and this is going to be Q of P. So consumer surplus at a certain price is just this region, right? Consumer surplus is the area between the demand curve and the price line. So S of P is easy. V of Q is the maximum amount consumers would be prepared to purchase the quantity Q. Okay, well, V, you know, take this Q here. How much are consumers prepared to pay to buy this quantity? Well, all of this area. Okay, so V of Q is this triangle plus this square. So I'll just write it there so you can see what it's both. That one plus that. I say there that V of Q is the area under the demand curve to the left of Q. That makes sense. So V dash Q P equals P. Is that obvious to you? So if we increase if we increase quantity by 1 unit, okay, so moving the new line up there, how much is V of Q increased? Well, it's increased by the height of this line, which is P. Does that make intuitive sense? So, you know, if you have an increased quantity by some unit delta, okay, then how much does V of Q increase? Well, it increases by a rectangle that's like delta times P. You can see it with integrals as well, if you like. So you can say V of Q is the integral from naught up to Q of the inverse demand curve. Let's actually use different. Let's say V of Q star, integral naught up to Q star of PQ, PQ. Okay, so then the derivative of that, okay, when you take the derivative of an integral, it's just the thing inside. Okay, so V dash Q star is just the price at that, at Q star.
So then V is only the square there. So
No, it's the whole thing. It's the triangle and the square. But when you increase Q, you know, if you like, you get this big rectangle and you lose a little triangle. But the little triangle is tiny. Okay, it's delta squared, so you don't have to worry about that. So V dash Q of P is P. Okay, so consumer surplus, we said S of P, we said V of Q was S of P plus P times Q. Okay. So S of P equivalently is the V of Q minus price times quantity. Okay, so the triangle is V minus the square. So if you take the first derivative of this, I think we've done something very similar in a previous lecture, so I know it's painful. If you take the first derivative of this with respect to price, well, if S dash P is going to be the derivative of this thing with respect to price, well, we use the chain rule. Okay, so derivative of the outside times derivative of the inside, minus derivative of this thing with respect to price. Okay, so using the product rule here. So derivative of P is 1. So we get Q of P, and then we get P times the derivative of this thing, P Q dash P. But we've already said that V dash Q of P is equal to P. So this thing is just P. This thing there is P. So we have P Q dash P, and here we have P Q dash P. So that term and that term cancels, and we have the S dash P is minus Q of P. So in fact, there's another way of saying the same thing, which maybe you find easier. So what we said is that all we've shown is that S dash P is minus Q of P. So the derivative of consumer surplus with respect to price is minus the quantity. So what happens when you increase the price? Okay, if you increase the price by delta, how much do you lose of consumer surplus? You lose this box here. Okay, how big is this box? Well, it's 1/3. Okay, so that's a graphical way of seeing the same thing. Maybe I should have gone straight into that. Okay, so all we've shown is that S dash P is minus 1. Okay, so if you increase the price, consumer surplus goes down by some amount given by the quantity. Okay, so we're going to define a few more things. I know this is painful, but it's going somewhere. So we say WA is the total social welfare when the amount of advertising A is performed. P of A is the price as a function of the amount of advertising performed. And pi PA is profits at a price P after performing advertising A. Okay, so that's the realized value of profits. Okay, so what's social welfare? Well, social welfare is consumer surplus plus profits. Okay, so welfare is the consumer surplus at a price given the amount of advertising plus for profit, so the price being the amount of advertising and the amount of advertising. Shit. Forgot the chart. So what happens to welfare as we increase advertising? Take the derivative of this. Well, here we're going to use the chain rule. Okay, so we get derivative of the outside times derivative of the inside. And here, have you seen how to differentiate functions in multiple arguments before? You must have done in first year. So you just take the derivative with respect to the first argument plus the derivative with respect to the second argument. Okay, so we get partial derivative of profits with respect to the first argument times the derivative of that first argument plus partial derivative of profits with respect to the second argument. Okay, but if a firm is acting rationally, it's going to choose price to maximize profits and it's going to choose advertising to maximize profits. Okay, so the condition for an optimum is going to say that this thing is equal to 0 and this thing is equal to 0 if the firm is sensible. So this is 0, all this drops out, and all you have is that the effect of advertising on welfare is just given by this thing. Okay? S-P of A we just worked out before. So S-P was minus Q of P. So the effect on welfare is this expression here, minus Q of P times P dash. Okay? So when is decreasing advertising going to increase welfare? Well, it's going to increase welfare just if this thing is positive. Okay, if this thing is positive, P dash A is positive, and when you decrease A, so if P dash A is positive, then this thing is positive, quantity is always positive, okay, so this whole thing is negative. So this is saying that the effect of increasing advertising on welfare is to decrease it. Okay, welfare decreases as advertising increases. Okay, so if P dash A is positive, okay, then this term is positive and this term is positive. So this means, and there's a minus sign there, okay, so this whole thing is negative. So this is saying that the derivative of welfare with respect to advertising is negative. Okay, so if advertising increases, welfare goes down. If advertising decreases, welfare goes up. So we have a sufficient condition for decreasing advertising to increase welfare. Okay, so just as we thought to start with, the important thing is just to look at the effect of advertising on the price. Okay, if advertising is increasing the price, then welfare is going down. If advertising is decreasing the price, then welfare is going up. Okay, so there's excessive advertising, if and only if cunning advertising would result in a falling prices. I don't suppose anyone has a Dell laptop, do they? I could just go to IT. Okay, but it's not completely clear that using a fixed standard actually makes sense, right? If advertising is genuinely changing people's preferences, then you ought to measure consumer surplus after we've seen the advert with respect to the new preferences, not the old preferences. Okay, here we were taking the old preferences both before and after, whereas it might make more sense to use the old preferences before and the new preferences after. Okay, so you see the advert, your preferences change, you now get extra consumer surplus from consuming the good. That ought to be factored into our welfare measure. Okay, so the standard thing to do is to use the consumer valuations both before and after if they see the good. And this is going to be valid as long as the advert doesn't change the value they put on other goods. Okay, so if an advert makes you like one good but dislike another, then the analysis would be a lot more complicated. So with the complementary and informative views, this is going to be the right thing to do. And I think this graph shows you everything you need to know. So here's the old demand curve. I maybe haven't labelled it as much as I should have done, but so here's the old demand curve, and here's the old price, this low line. Okay, so where a price line intersects the quantity line, we have this point, which is the quantity of old demand and old price. Okay, so this is where you start out. And then along comes the advert. The advert has two effects. Okay, firstly, it shifts demand outwards. Okay, so rather than being this demand curve, we're now on this demand curve. But it also makes the firm realise that they can charge a higher price. Okay, so rather than charging this price, they go to charging this price. So the new quantity that's being demanded is this one. Okay, this is the new price. This is the new quantity demanded. Okay, so this is the point we ought to be looking at. But what's done in the fixed standard approach is to look at the old quantity, the old demand curve, but the new price. Okay, so this is the old demand curve with the new price intersect here. Okay, so whereas in the Dixit-Norman approach, what we were just looking at, the fixed standard approach, all we get is this lost area. The prices increase, so we just lost some consumer surplus. Okay, because we haven't taken into account the fact that the demand curve has shifted out, but preferences have changed. So this shifting out of the demand curve means consumers haven't just lost this area, they've also gained this extra area. Okay, they now value the good more highly, so they're getting some extra consumer surplus from consumers. Okay, so some area you gained, some area you lost. It's ambiguous whether or not advertising is going to be good or bad. And using these non-fixed standards are going to moderate results about excess advertising. So in the Dixit-Norman world, yeah, you'd probably conclude there was too much advertising if you're using a fixed standard. But once you start using a non-fixed standard, it's a lot less clear, okay? Because there's this positive effect that's counteracting the negative effect. So if the prices don't change following an advert, then you can probably safely conclude that there's insufficient advertising. Okay? In the Dixit-Norman world, if the prices don't change, welfare just stays the same. Now, if prices don't change, we don't have this effect, but we do have this effect. Okay, so if prices don't change, advertising is probably a good thing. And there are some examples in Bagwell that show that you can get insufficient advertising even when advertising does push up prices. And some sufficient conditions are here. So if it's the case that when quantities are higher, the effect of advertising on prices is smaller. Okay, so when people are demanding a lot anyway, it doesn't make too much difference whether or not they see an advert. So with informative view, you might think that's true. You know, if everyone is already getting the product, then it doesn't matter if they see adverts telling them that the product exists because they're already going to buy the product. They already knew it existed. So maybe that's plausible in that case. And you also need it to be true that increasing advertising increases quantities. Okay, so you know, in this graph, the way I've drawn it, increasing advertising was increasing the quantity. It is the opposite. So if these two conditions are satisfied, then yeah, it turns out that the marginal consumer is getting the least benefit from the advertising. Okay, so the firm effectively only cares about the marginal consumer. You know, you set the price in order to persuade the marginal consumer to buy it. Okay, so there's going to be too much. I'm waiting for my battery to die. It's amazing it hasn't yet. So it's kind of hard. It's not very practical to look at welfare with these non-fixed standards in general, but in this case with informative advertising, okay, where advertising is scaling the demand curve, we can do it and it's not too difficult. So what's consumer surplus in that case? Well, overboard. demand curve. Okay, so we've got some point P star. Okay, so one way of thinking about consumer surplus, okay, you can either think about doing the integral along this line, okay, and then take away the box. Or you can kind of think about rotating the diagram by 90 degrees, okay, taking the integral along this line. Okay, so we start at P star, we go up to infinity. You know, let me just draw the same diagram but rotated 90 degrees. So we're just swapping the axes on the diagram. Okay, so quantity is now on the vertical axis. Okay, so here's P star. Okay, so this area was consumer surplus. We've just rotated the diagram by 90 degrees. This area is consumer surplus. Okay, so you can think of this area as the integral of this line, okay, from P star, up until infinity. Can you see that on that slide? Okay, so one way of measuring consumer surplus is this thing. So QPA, well, we said that was FA times GP. Let's plug that in. F of A is the function of price, so that just drops outside the integral. Okay, so it's F of A times this thing. So that's what consumer surplus is. Total surplus is consumer surplus plus producer surplus. Okay. Okay, so this was the consumer surplus bit, and then we have some producer surplus, which is profits. So what's the effect of advertising on welfare here? Let's take the derivative of this thing. So using the so we're going to get the derivative of this, which is f dash a, times the derivative of this with respect. There would be another term with the derivative of this with respect to advertising. Okay, but advertising doesn't occur in here. So when we take the derivative of this with respect to advertising, we just get f dash a times the integral. Okay, and then we're going to get a final term, which is the derivative of the profit with respect to advertising. Okay, but the firm is going to choose the amount of advertising it performs in order to maximize profits. Okay, there's going to be a first order condition for that, and that's going to say that the derivative of profits with respect to advertising should be equal to 0. So at an optimum, this thing is equal to 0, this bit drops out. Okay, so the effect of advertising on welfare is just given by this expression. So we just need to know whether this is positive or negative, right? So advertising is informative, we're thinking. Advertising scales with demand, increases with demand at any price. This thing is positive. Okay? And this is kind of consumer surplus when this happens to be equal to 1. Okay, this is positive. It's an integral of a positive function. It's like the demand. Okay, so there's something positive times something positive. So increasing advertising here will always increase welfare at the margin. So if the firm is choosing advertising optimally, it's always going to choose too little with respect to total welfare. Okay, so the firm will choose an amount of advertising A star. The social planner would like to produce a bit more advertising. And this is just because advertising is scaling demand up, new people are getting the product, that's creating extra consumer surplus. Before, those people weren't buying the product at all, now they are, they're getting some consumer surplus from it, that's good. Okay, so there's too little advertising in this informative work. Okay, so to summarise so far, we'll do a bit more on advertising in the last lecture. We've got these 3 different views about how advertising works: complementary, informative, and persuasive. The Bagwell paper is a really good summary of this literature. Okay, so if it happened there was an essay question on advertising in the final exam, I don't know why there might be, then having read that Bagwell paper might prove useful. Okay, it's not always bad, okay? It's quite easy to construct these examples when there's too little advertising or when it increases welfare. And with persuasive advertising, we found these ambiguous effects. It's an exercise.